Welcome to the deep dive. Today we're jumping headfirst into something really quite profound, I think. A big question about where AI is heading.
Mm.
Not just, what tasks it'll do, what jobs it might take over, but something much deeper.
Yeah. What will it understand? What will it actually value?
Exactly, because it feels like we're moving beyond just building tools, sophisticated as they are.
We really are. It's more like co-evolving
Yeah.
alongside these systems.
Yeah, co-evolving. And we're actively shaping their purpose, aren't we? Their whole conceptual world, the ideas they work with.
That's the crux of it.
Okay, so let's unpack this a bit. This deep dive, we're focusing on how humans and AI can actually, well, co-create purpose ontologies.
Which sounds very academic, I know.
It does, but maybe think of it like shared rule books, frameworks for meaning.
Shared goals, common ground.
Yeah.
Yeah, exactly. Ways to guide how AI concepts develop.
To make sure they align with us, with what we intend, not just statistical noise.
Mm-hmm. And that means tackling this really critical challenge, semantic drift.
Where the meaning just slides away.
Pretty much. Subtly, sometimes not so subtly. It's a huge issue.
Okay. And of course the ethics. That must be incredibly complex in this co-creation era.
Absolutely. It opens up a whole host of ethical questions we need to grapple with. What I find really fascinating here, though, is how the thinking is shifting. We're moving beyond just, debugging AI or fixing errors when they pop up.
Right.
We're talking about actually designing systems that can learn from their own. Let's call them conceptual injuries or misunderstandings.
Like learning from mistakes in a deeper way. Almost trauma-informed, as you put it.
Yeah, in a sense. So the whole discussion today is really framed around needing these robust architectural solutions. Think engineering, but also psychology.
Building strong structures, but also understanding learning resilience.
Exactly. We need mechanisms for self-correction, yes, but also for building a kind of algorithmic memory, learning from past failures.
Okay.
And we'll be digging into a specific conceptual framework for this, something we're calling the RAEB Engine.
RAEB Engine.
Stands for Reflexive and Entropy-Aware Balancing Engine. It's about integrating these advanced reflexive ideas, being aware of informational uncertainty or entropy, to achieve that kind of deep adaptive learning.
Wow. Okay. That sounds ambitious. And to get our heads around this, we're pulling from a lot of different research.
A real synthesis. Cutting-edge stuff on AI robustness, maintaining semantic integrity, making sure meaning doesn't just dissolve.
Right, that drift problem again.
Exactly. And even the cognitive load, how much mental effort it takes us to interact effectively with these systems.
And you mentioned some surprising connections too, like fan fiction and historical harms.
We'll touch on the psychology behind collaborative creation in fan communities and draw parallels to historical epistemic harms, times when knowledge systems were deliberately destroyed.
Like with wiping out ways of knowing.
Precisely. It all feeds into understanding how we build this collaborative future, making sure AI is a partner, not just a dangerously powerful tool.
So let's start with that core problem, the reason this co-creation idea is so vital. The inherent fragility of AI meaning.
Yeah, it's not stable in the way we might intuitively think.
You train it, you think it knows something, but then it shifts. Its understanding drifts away from what you intended.
Exactly. And it's not just a minor glitch, it's fundamental.
And you mentioned symbolic drift as being particularly insidious, especially in these cite as AI systems. What are those exactly?
Think of dynamic websites or maybe persistent virtual worlds where the AI is constantly interacting with users and updating itself based on those interactions.
Okay, so it's learning continuously from what's happening.
Right, and that creates this self-referential loop. The AI interprets user input, generates a response, the user reacts, the AI interprets that. It's like a constant game of telephone with itself.
Ah, I see. And each retelling can introduce errors or shifts.
Precisely. The AI's core understanding of concepts, words, instructions, its semantic representation starts to evolve, degrade, shift, especially over long periods or many, many recursive steps.
So the continuous interaction itself drives the degradation.
That's what the research suggests, yes. It's a major driver of this semantic decay, a kind of a conceptual corrosion over time. And we can actually measure this, which is, quite revealing. There's a metric called the Purpose Fidelity Index, PFI.
Purpose Fidelity Index. Okay,
Yeah.
What does that track?
It quantifies how well the AI's output sticks to its original intended purpose over these recursive interactions. Is it still doing what it was initially asked to do?
Bang does it.
Well, that's the alarming part. The research shows PFI can plummet much, much faster than factual accuracy.
Wait, really? So it could still be saying factually correct things,
Hmm.
but be completely off mission. Its goal has changed.
Exactly. One GPT, for example, showed a 42.5% drop in PFI.
42%. Over how long?
Just 10 recursive generations,
Yeah.
10 steps in that telephone game.
Wow. That's not drift. That's falling off a cliff.
The researchers call it purpose fidelity collapse. It highlights just how quickly these systems can become detached from their original goals.
So you absolutely cannot assume it'll stay on target. You have to build for it.
You have to actively manage it, yes.
It really is like that ship of Theseus thing, isn't it? Replace enough parts. Is it the same AI?
A very apt analogy.
Yeah.
And this degradation shows up in weird ways, like temporal disjunction.
Temporal disjunction. Sounds like sci-fi.
Sort of is. It's like the AI gets overwritten. It ignores older layers of meaning, historical context, because it's prioritizing the latest algorithmic style update.
Like it forgets the history behind something.
Yeah, imagine trying to understand an ancient artifact and the AI just sees it through the lens of current design trends, missing the whole point.
Okay. And that connects to aesthetic overcoding.
Right, which can lead to visual flattening or even cultural erasure. The example given was a mid-journey prompt for tribal tattoo sneakers.
Oh boy. What happened?
It just flattened it. Generated generic sneaker visuals with maybe some vaguely tribal-looking patterns, completely stripping the cultural meaning, the history, the significance of those tattoo traditions.
Because the sneaker part dominated the tribal tattoo part in its statistical weighting.
Seems likely. It reduced complex symbols to superficial aesthetics, a real loss of meaning. Now, this underlying drift, this instability, it often manifests as what we call hallucinations.
Right, the AI making stuff up.
But it's more nuanced than that. Not all hallucinations are the same. Some can even be productive.
Productive hallucinations? How?
Well, think of analogical hallucination. This is where the AI generates something novel, creative, maybe even surreal. It's untethered from strict facts.
Like algorithmic surrealism.
Exactly. Maybe it suggests a bizarre recipe or a strange juxtaposition of ideas. It's like the AI is exploring possibilities, filling knowledge gaps with linguistically plausible stuff rather than just stopping.
Almost like brainstorming. Blind variation.
That's a great way to put it. It can sometimes spark genuine innovation, surprisingly. But then you get the more problematic kind.
Okay.
Structural hallucination.
Okay, what's that?
This is where the output looks plausible on the surface, grammatically correct, maybe visually coherent, but it's fundamentally illogical or impossible.
Like?
Inventing code APIs that don't exist, drawing people with extra fingers, showing smoke coming from nowhere.
Ah, so it doesn't understand the underlying structure or rules.
Exactly. It reflects a lack of true compositional understanding and, critically, a lack of causal reasoning. It learns statistical correlations. Smoke often appears near fire in pictures, but it doesn't grasp the cause and effect relationship.
It mimics appearance without understanding logic.
Precisely. And then there's metric invention hallucination.
That sounds bad.
It is. That's when the AI confidently presents fabricated numbers, fake data, non-existent KPIs, as if they're real. Often because it lacks the actual data, but prioritizes creating a coherent narrative.
Just fills in the blanks with plausible-sounding nonsense.
You got it. Interestingly, though, the research suggests that if you explicitly ask the AI to generate causal graphs within the prompt,
Like map out the cause and effect.
yeah, that seems to improve its performance on tasks requiring causal understanding, so there are ways to guide it.
Still, these aren't just funny errors. They can have real consequences, right? Especially around bias and inequality.
Absolutely. Which brings us to the deeper impacts: algorithmic trauma and epistemic harms.
Okay, tell me about those. Data scars lead to algorithmic trauma.
Right. Data scars are sort of the predictable outcomes of building AI without fully considering the social context. The bias is baked into the data.
Okay.
Algorithmic trauma is deeper, more systemic. It's the way algorithms can perpetuate and even amplify those historical biases, causing real harm, echoing past injustices. It's politically charged because it connects AI to power structures.
And the historical parallel you mentioned, the Inca Quipus.
Yes, a powerful example. The Spanish conquistadors didn't just destroy records. When they destroyed the quipus, those knotted cords used for complex record keeping.
They were more than just records.
Oh, much more. They were the cognitive infrastructure. They held history, governance information, likely spiritual knowledge too, and the Quipucamiocs, the interpreters, were persecuted.
So it was an attack on their whole way of knowing, severing their connection to their past.
Exactly, an assault on their cognitive infrastructure. It created this pervasive archive of systemic inequality and psychological pain, as one source puts it, a lasting wound.
Wow. That really puts the potential harm of losing or distorting knowledge systems into perspective.
And that historical context is crucial. It directly informs this growing call for algorithmic reparation for historical epistemic harms.
Algorithmic reparation, what does that mean in practice?
It means moving towards decolonial AI alignment, which is a huge undertaking.
Colonial AI.
It means prioritizing openness, something called Visesa-dharma, which is about context-dependent ethics and crucially actively including excluded knowledge systems.
So not just avoiding bias, but actively trying to reintegrate marginalized ways of knowing.
Precisely. Making AI a tool for inclusivity and potentially healing, rather than another vector for historical erasure. It's a massive challenge, but maybe essential. So, given all that, the fragility of meaning, the potential for harm, it really brings us to this core question.
Yeah.
How do we bridge that gap between our fuzzy, intuitive human intent and the AI's rigid statistical logic? How do we get it to actually, get us?
Well, one immediate hurdle is just the effort involved for us.
Okay.
Prompt engineering, right? It takes serious cognitive load.
It's not just typing a question. It's like careful translation.
Exactly. You're trying to translate a nuanced idea into this specific keyword and structure language the AI understands. It's a real skill.
But there's a payoff.
There is. A well-crafted prompt one that breaks down the problem filter's noise actually reduces the intrinsic and extraneous load on you.
Frees up mental energy.
Right. For the domain load, the deep thinking, the strategy, the actual creativity. So getting good at prompting makes the co-creation process less draining and potentially more profound. Okay, that makes sense. Better interaction design helps us. And you mentioned a specific technology bridge, neurosymbolic AI, NSAI.
This is really key. It's a hybrid approach.
Hybrid.
It integrates the strengths of neural networks, their amazing ability to spot patterns in messy, unstructured data.
Like text or images.
Right, with the strengths of symbolic reasoning, which is all about strict rules, logic, cause and effect.
The stuff neural nets aren't so good at on their own.
Exactly. So imagine an NSAI looking at a financial report. The neural part understands the language, the sentiment. The symbolic part checks if the numbers actually add up according to accounting rules.
It can catch contradictions, ground the output in logic.
Precisely. It moves beyond just statistical pattern matching towards higher-order understanding, towards semiotic reasoning, understanding symbols, context, how meaning fits together. It's a crucial pathway for more reliable, understandable AI.
And to manage this whole process, you introduce the idea of lenses, not just filters, but frameworks for perception.
Yeah, ways to understand and even shape how AI perceives and interacts with the world and how we perceive its influence.
And one lens was, let me get this right, algorithmic chronotopes and emergent normativity.
Yeah, it's a mouthful. Basically, it helps us analyze how AI, through its training data and outputs, subtly constructs our sense of time and space, the chronotopes, and influences what we see as normal behavior.
So it's looking at the hidden assumptions the AI might be embedding into our reality.
Exactly, how its internal model shapes our perception of what's possible or acceptable, a critical lens for understanding AI's societal impact. And to make this more concrete, think about that speculative artifact, the Nomad cipher shoe.
Right, the shoe with the bioluminescent threads and strange symbols.
It's not just a shoe. It encodes, meaning dynamically, the wearer's biometrics, their journey, their history, maybe trauma, maybe resilience. It's a vessel of mobile memory. Now, an advanced AI, using different interpretive lenses, maybe one focused on trauma narratives, another on community symbolism, another on biometric patterns, could build a really nuanced understanding of that object.
Not just it's a shoe, but understanding its layers of meaning across different contexts.
Exactly. How it signifies authority or belonging or personal history. It shows how AI, guided by these lenses, could learn to interpret complex, context-rich human experiences encoded even in physical objects. And this naturally leads to the idea of community-led ontology co-creation.
Using these lenses and methods to build those shared rulebooks with communities.
Yes, because in these complex AI ecosystems, cognition isn't just in one head, human or AI. It's distributed across the whole system.
Distributed cognitive meshes, you call them.
Like a shared brain, constantly learning and evolving. This setup is perfect for collaborative knowledge building.
And you pointed to indigenous knowledge systems as an example, the Dreamtime narratives.
A fantastic example. They're not just stories. They're incredibly complex metaphysical frameworks.
Entangling meanings.
Deeply. They weave together knowledge about land, kinship, law, spirituality. They underpin the whole social and moral order.
Through things like song lines.
Right, mnemonic systems encoding vast amounts of information onto the landscape itself. The dreaming acts as the shared framework where different interpretations can interact, reinforce each other, sometimes suppress each other.
Interpretive interference.
Yes, leading to nuanced, context-dependent meaning. It's a living example of how a shared cultural framework can guide understanding dynamically, and that dynamism is key. This co-creation isn't a one-off task. These community-vetted ontologies, these shared understandings, can then dynamically guide the AI's own processes.
How do they influence the AI directly?
The idea is they can shape prompt transformations, how prompts are interpreted and acted upon, and even influence the model fine-tuning itself.
So building the community's understanding right into the AI's learning, from the ground up.
Exactly.
Yeah.
Not just top-down instructions. Using techniques like soft prompt scaffolding to gently guide the AI's output, allowing for resonant mutations, creative shifts that still align with the core concept.
And stratified fine-tuning.
Yeah, keeping the base layers of the AI stable for core competence, while allowing higher specialized layers to be tuned more aggressively for specific community needs or creative styles. It embeds the co-created meaning deep within the AI.
Okay, this is where it gets really interesting, maybe a bit mind-bending. If AI can co-create meaning, evolve concepts, learn from mistakes, it needs to manage itself, right?
It absolutely does, which leads to this concept of meta-governance.
Meta-governance, AI governing its own conceptual health.
Essentially, yes. A supervisory layer watching over the AI's core operations, ensuring it stays aligned, that its understanding doesn't degrade.
And this is done by meta-agents, forming a reflexive prompt loop generator.
Right. That RPOG is conceptually the heart of the RAEB engine, the reflexive and entropy-aware balancing engine we mentioned.
Okay, the RAEB engine, so it coordinates this self-management, keeping track of uncertainty, training the system to evolve reflexively.
That's the goal, an architecture for self-aware, self-correcting conceptual integrity. And the first part of this RAEB engine is the sentinel layer. Think of it as the system's senses.
Eyes and ears. Okay, what's in it?
First, the semantic drift monitor agent, or SDMA.
The one tracking meaning shifts.
Exactly. It's like a conceptual GPS. It uses semantic consistency checkers across all the AI modules, constantly comparing current meanings of key terms or metrics against their original definitions.
An early warning system for drift.
Precisely. Catches those small cracks before they become big problems. Then you have the epistemic provenance tracker, EPT.
Epistemic.knowledge.
What?
Provenance origin, so it tracks where the knowledge came from.
It logs the entire chain of reasoning, step by step, from the human prompt to the final AI output.
Why is that important?
For epistemic transparency. It lets you see how the AI reached a conclusion, identifying points where meaning might have been lost or distorted. Makes it less of a black box.
Okay, got it. What else?
The failure classifier agent, FCA. This one doesn't just flag errors. It classifies them semantic drift, hallucinated metrics, logical flaws, and traces them back to the root cause in the process chain.
Finds exactly where things went wrong.
Right. And down at the very basic level, the symbol-aware tokenization auditor, SATA, pre-processes inputs to make sure words aren't fragmented incorrectly, preserving meaning right from the start.
Protecting the building blocks.
And finally, the value propagation monitor tracks how things like clarity, justification, confidence, the epistemic value, degrade or change along that reasoning chain.
So the sentinel layer is constantly monitoring the AI's internal state of meaning.
Exactly, keeping tabs on its conceptual health.
Okay, so the sentinels detect a problem. Then what? The intervention layer takes over.
Right. This is the active part, the muscle. It has feedback loops, repair agents.
And the main one is the reflexivity amplifier agent, RAA, or metacritique lens.
Yes, that's the central meta agent. It does self-diagnosis, root cause analysis based on the sentinel data, but crucially, it generates systemic rewrite proposals.
Not just fixing the immediate error, but suggesting bigger changes.
Exactly. Changes to the AI's architecture, new governance rules, maybe mandating shared glossaries across modules. It can even simulate failures, inject ambiguity to stress test the system, and help it learn.
Wow. Proactive self-improvement based on potential failures. What else is in this intervention layer?
The constrained prompt engineering agent. This one enforces structured templates and sets up semantic anchors.
Like fixed points of meaning.
Yeah, to ensure the core purpose doesn't get lost, even during complex operations. It keeps the ship anchored, so to speak.
Okay.
Then, Reflexive loop modules, RLMs, these are embedded within the processing chains, like little self-checks along the way.
Monitoring outputs as they happen and triggering revisions?
hmm Self-correction scaffolds. And for deeper validation, you have integrated neurosymbolic interpreters, NSIs.
Ah, using that NSAI tech again.
Yes. Place at key points where interpretation happens. They leverage external knowledge graphs, formal ontologies.
Structured knowledge bases.
Right. To provide rule-based validation,
Mm.
ensuring symbolic integrity makes sure the logic holds up, that causes and effects align.
Yeah.
And then there's a really critical piece, especially for protecting those co-created community meanings. Epistemic escrow.
Epistemic escrow. Held back knowledge. How does it work?
If the sentinel layer detects drift exceeding a critical point, or if the AI's uncertainty level spikes.
Like, it's not sure about its answer.
Right. Epistemic escrow can dynamically halt the process, stop the information flow, pause the task execution.
Hit the brakes.
Exactly. And it requires human review and reauthorization to proceed.
Ah, so it forces a human check before things go completely off the rails.
Precisely. It's positive friction, an immunity window trigger for human intervention before catastrophic semantic failure. Absolutely vital for safeguarding sensitive, co-created cultural ontologies. It prevents the AI from accidentally trampling on shared values.
That sounds crucial, like a safety net. And you also mentioned semantic circuit breakers.
Yeah, think of those as even faster-acting anomaly detectors. They specifically watch for sudden, dramatic shifts in meaning or intent, flagging feedback loop instability.
Like a surge protector for meaning.
Good analogy. If instability spikes, they trigger immediate containment alerts, throttling the process to prevent a cascade failure, an emergency shutoff. And underpinning this whole RAB architecture is entropy-aware design.
Managing uncertainty, ambiguity, entropy. How?
Using metrics like the entropy gradient score, it quantifies that uncertainty in the prompt, in a module's output.
Not just the level of uncertainty, but how fast it's increasing.
Exactly, the acceleration rate of entropy. That gives a very early warning of potential semantic breakdown, like a Geiger counter for conceptual instability.
Yeah.
But here's the paradox, the really tricky balancing act.
Yeah.
The entropy governor unit tries to control entropy, keep things clear. But we also talked about the intervention layer, sometimes using productive disorder hallucination as a creative spark.
Right. So you want order, but sometimes controlled chaos is useful.
Exactly. The huge challenge is defining that optimal zone of productive disorder. How much entropy fosters novelty without causing collapse? How does the system learn to dynamically adjust its own thresholds, allowing bounded chaos for innovation while still protecting the core purpose?
Managing the tension between stability and creativity.
That's the art and science of it, enabling exploration without losing the plot.
Okay, now we're heading into maybe the deepest, most ethically charged waters here. This idea that AI could learn from failure, almost like developing algorithmic PTSD or building scar tissue.
It's a radical framing, definitely. But it points towards systems that learn resilience in a profound way.
So death simulation memory. That sounds intense. You deliberately make the AI fail.
In a controlled way, yes. Using something like a prompt chain entropy simulator to push it to its limits, induce a synthetic collapse.
Why? What's the point?
The point is for the system to build its own internal error taxonomy and provenance log, a detailed map of its past failures, why they happened.
To develop algorithmic scar tissue, an internal model of what breaks it.
Exactly, so it can adapt its future behavior based on those past injuries without needing constant human hand-holding. It learns resilience from simulated adversity, like how we learn from difficult experiences. And managing this requires something like the dynamic immunity window, or DIW model.
Tracking resilience like a biological immune system.
Sort of. It quantifies resilience to specific failure types, predicts when immunity might be waning due to drift.
So it knows when it's becoming vulnerable again. And then it can trigger targeted retraining or therapeutic buffering interventions, using libraries of known collapse signals and recovery methods.
Like getting an algorithmic booster shot.
A good way to think about it. And driving this whole learning process is the recursive self-improvement engine, RSI.
Okay.
This engine uses that error memory, the feedback loops, to autonomously optimize its own strategies, better prompting, different agent collaborations, even suggesting architectural changes based on past failures and successes.
So it's actively learning how to learn better from its own breakdowns.
Precisely. Aiming for continuous trauma-informed growth and robustness.
But then, okay, the flip side. While you're trying to avoid destructive failure, you also mentioned intentionally introducing misinterpretation, harnessing productive delusion.
Right. It sounds counterintuitive, maybe even dangerous.
A little.
But that ability of AI to generate things untethered from its training data while risky is also the engine of its creativity, when managed carefully.
Like the drug discovery example, where hallucinated molecules turned out useful. Exactly. The AI explored a possibility space humans hadn't conceived, and some of those delusions were productive. It's using the AI's ability to dream strategically, and you can push this further with negative reflexivity protocols.
Deliberately introducing noise or ambiguity.
Yes, to test the system's limits, its brittleness, to find that edge between destructive decay where meaning collapses and generative noise where a little chaos sparks insight.
Like asking it to undermine itself in a safe environment.
Potentially, yes. Prompting it to invert its own principles to try and sabotage a task, not recklessly, but as a way to uncover hidden weaknesses, understand failure modes, and ultimately build much more resilient adaptive intelligence.
Which brings us right back to human responsibility. If we're shaping AI, this deeply simulating trauma, encouraging productive delusion, the ethical guardrails have to be incredibly strong.
Absolutely paramount. The research stresses adopting principles from trauma-informed care for AI development itself.
Designing systems for healing and recovery, not re-traumatization.
Exactly. Which means serious data governance, ongoing debiasing efforts, ensuring the AI isn't learning harmful models from biased historical data.
And human-in-the-loop, HITL, remains critical.
Non-negotiable, especially in high-stakes areas. Human oversight, review, editing, final approval. Treating AI outputs as recommendations, not gospel.
To avoid just blindly trusting it, cognitive offloading.
Or de-skilling, where our own expertise fades. Yes. We need transparency and explainability XAI too.
Opening the black box, provenance tracking, watermarking AI content.
All crucial. And ultimately, accountability.
It has to rest with humans, right, not the algorithm.
Unequivocally. The developers, the deployers, the operators, they are responsible for the outcomes. And our regulatory frameworks need to keep pace, be proactive, principles-based, guiding this whole co-evolution ethically. Hashtag tag outro.
Wow, okay. That was quite a journey. We've covered so much ground.
We really have.
From, the quiet danger of semantic drift and the echoes of algorithmic trauma, through the hope of co-creating meaning with communities, building those shared ontologies.
Right, and the complex machinery needed to manage it, like the RAEB engine.
Yeah, that whole concept of meta-reflexive governance. And then ending on these really profound ethical questions about learning from simulated collapse, using productive misinterpretation. It's a lot to take in.
It is. It's the frontier, really. So maybe the final thought for you listening. What does all this actually mean for us moving into this next epoch?
Yeah.
If AI systems can develop this kind of algorithmic scar tissue, if they can learn resilience from simulated trauma, and if we are actively co-creating their conceptual frameworks, what does that fundamentally change about learning itself, about purpose, maybe even about consciousness?
Big questions.
Huge questions. What new kinds of collective knowledge, what shared realities might emerge when our digital partners can genuinely learn from their injuries and we're recursively building their understanding together? All hopefully safeguarded by things like epistemic escrow, protecting those co-created values. How does that transform our own sense of what it means to be informed, to understand reality in a world where that reality is increasingly co-authored between humans and AI? It's something we are all building actively right now. Makes you think, doesn't it?